Well, first of all, it is a Big Bang model. In other words, there is a Big Bang, but the Big Bang was not the beginning. You might think they're very different from each other. The Big Bang is very, very dense and very, very hot, while the remote future will be very, very rarefied and very, very cold. The once unquestionable Big Bang theory is now under the relentless scrutiny of legendary physicist Roger Penrose. The latest discovery hints that the universe might be hiding secrets that will shake the very foundation of our cosmic origins. Forget everything you thought you knew about the Big Bang theory. Embrace yourself. Penrose's theory suggests that the Big Bang might not be how our universe came into existence. Is the Big Bang really just a chapter in the story of our cosmic origin? If yes, what alternative theories explain the beginning of our universe? Join us as we delve into the words of Roger Penrose. We detected a hint of the previous universe that existed before the Big Bang. The prevailing theory in science and astrology is that more than 13.8 billion years ago, the universe was in an intensely hot and dense state known as the Big Bang. However, recent imagery captured by the James Webb Space Telescope, JWST, challenges this popular scientific understanding. While these images may captivate the general audience, they are causing ripples of concern within the cosmological and astronomical communities. Experts are surprised by the differences these images introduce to the long-established Big Bang theory. This newfound data has triggered significant unrest in the scientific community, leading astronomers such as Alison Kirkpatrick from the University of Kansas to reevaluate the validity of their prior research. The focal point of the unrest is the characteristics of the galaxies portrayed in the JWST images. Contrary to scientists' expectations of the Big Bang theory, these galaxies appear unusually small, smooth, and remarkably old. According to the theory, as space expands, galaxies and other celestial objects should appear bigger as they move away from us due to the stretching of light. However, the JWST images reveal a confounding phenomenon where galaxies seem to reduce in size as the distance increases. Even galaxies with greater mass and brightness than our Milky Way appear 2 to 3 times smaller in the JWST images compared to previous observations by the Hubble Space Telescope. Moreover, the observed redshifts in these galaxies are 2 to 3 times more pronounced, further questioning the assumption of an expanding universe in the Big Bang theory. These observations imply that distant galaxies must be tiny to account for this optical illusion, which appears implausible. These tiny and smooth galaxies undermine the notion of expansion, casting doubt on the validity of the Big Bang theory. Initially, proponents of the Big Bang theory recognized that their assumptions required the existence of small and dense galaxies, informally known as Mighty Mouse galaxies, based on earlier observations from the Hubble Space Telescope. However, the situation has been further complicated by JWST images, which question whether these compact galaxies could transform into larger ones through collisions or expansion. The JWST images portray well-defined spiral structures and smooth disks resembling galaxies observed in the present day. This contradicts the anticipation of rough and distorted galaxies resulting from collisions. Without significant mergers, these minute galaxies cannot grow 100 times larger, thus challenging the concept that they were initially small. This revelation disputes the optical illusion predicted by the expanding universe theory, suggesting a potential absence of expansion and no Big Bang. The age and abundance of galaxies in the JWST images present further challenges for the Big Bang theory. By using infrared filters, the JWST captures the colors of distant galaxies, allowing astronomers to estimate the age of the stars within them. According to the theory, these galaxies should represent approximately 400 to 500 million years after the Big Bang. However, some of these galaxies exhibit stellar populations over 1 billion years old, contradicting the assumption that nothing could have existed before the Big Bang. Furthermore, theorists expected that as the JWST delved deeper into space and farther back in time, there would be fewer galaxies and eventually a dark age. However, the images reveal galaxies as large as the Milky Way even just a few 100 million years after the Big Bang arose. Additionally, the number of galaxies observed at redshift above 10 is at least 100,000 times greater than predicted by theorists. The formation of so many substantial galaxies in such a condensed time frame challenges the Big Bang theory. These discoveries have also sparked a re-examination of the concept of time. Some scientists propose that time is merely a human construct, serving as a tool to distinguish between the present and our perception of the past. They posit that time is an illusion created by human memories, suggesting that all events, past and future, happen simultaneously. This perspective challenges the traditional notion that time progresses strictly in a forward direction. Certain proponents of the Big Crunch theory go even further, suggesting that time may reverse if the universe stops expanding and begins contracting. This reversal could result in an undoing of the cooling and expansion observed in the Big Bang, ultimately leading the universe to collapse back to its point of origin. The consequences of what follows a Big Crunch remain uncertain, but there are various theories. Some propose a fresh start with another Big Bang, while others suggest the possibility of the universe simply ceasing to exist. Some ideas entertain a cyclical nature, repetitively creating multiple universes. The ongoing debate about the direction of time has prompted scientists to question its fundamental nature. Some advocate for a block universe concept, wherein space and time are intricately interconnected in what is known as spacetime. Drawing from Albert Einstein's theory of relativity, the block universe viewpoint asserts that time and space form part of a four-dimensional structure where each event has its position in spacetime. This implies that past, present, and future coexist in spacetime, making them equally significant. Physicist Max Tegmark from the Massachusetts Institute of Technology seeks to address this concept by suggesting that reality can be depicted as either a three-dimensional space where events unfold over time or a four-dimensional space where nothing changes. If the latter is true, it implies that everything already exists at any given moment, encompassing the past, present, and future. However, the illusion that the past has occurred and the future is yet to come leads us to perceive change. Julian Barbour, a British physicist renowned for his extensive writings on time, provides a unique perspective. He likens our experiences to a series of nows, emphasizing that our awareness is limited to our brain state. According to Barbour, the perception of the past arises from storing memories in our brains. Drawing from the space-time theory, Barbour introduces the concept of Platonia, where each point represents a now. He suggests that what we commonly perceive as the past is an illusion crafted by our brains. This discussion circles back to Albert Einstein's theory of space-time, which has stirred confusion in the field of physics. Scientists are now contemplating the potential consequences if Einstein's theory were proven incorrect. Could discarding the space-time theory lead to a better understanding of the universe? Such a development would mark a significant milestone. Throughout history, scientific revolutions have been pivotal for progress. Dissatisfaction and doubts often pave the way for new theories to replace old ones, a pattern witnessed in astronomy and physics. In the early days, humanity believed that Earth was at the center of the solar system, a notion that persisted for over a millennium. However, Nicholas Copernicus proposed a heliocentric model, suggesting that Earth is another planet orbiting the Sun. Despite initial resistance, this model gained support with the advent of telescopes. Isaac Newton further contributed to our understanding by explaining that the Sun's gravitational force causes planets to orbit it. Newton's theory dominated scientific thought for nearly 300 years until Albert Einstein introduced his general theory of relativity in 1915. This new theory effectively explained the quirks in Mercury's orbit and received strong confirmation during a 1919 solar eclipse near Africa. Unlike Newton's idea of gravity as a force, Einstein saw gravity as a result of space bending. He suggested that everything in the universe exists in a four-dimensional structure called spacetime, and big things like the Sun make this structure curve. This curve affects how planets move, and observers see it as a pull, similar to Newton's description. Einstein's spacetime theory continues to shape our understanding of the universe, yet it faces scrutiny and challenges as scientists delve deeper into the mysteries of existence.